Alright, here's a little demonstration of wireless transmission of energy using one of these free spin devices that I've shown in several videos that uses the drive unit out of one of those solar powered toys, and that's the little circuit board, the capacitor, and that's the coil that spins the rotor. And this is another rotor design right here. And what I've done is I've replaced the solar panel with these diode arrangements that are called Avramenko plugs. They're 1N4148 switching diodes. One goes one way, one goes the other way, and they form a way to take a signal in and split it to drive different things. I've got a piece of aluminum on the bottom here that's going to act like a ground plane for this. And then I'm going to put this rotor on here, stop it, so you see it's not moving. It's got very, very little friction, and these devices require that there be a very, very little friction for it to work. Now what I'm going to drive this with is this. This is my Mini Tesla Coil here that you can go back in my video file and see this. It's a Slayer exciter design, and it's one of my most popular videos. And this is by GBluer here at YouTube, and it's just a variation of his Slayer exciter, but it does some phenomenal things. And there was a kind of a study of it a while back, and they decided that this was really like a Tesla coil, only it only runs in the hundreds of volts, not thousands of volts. So it's not like a standard Tesla coil. It's just the principles are very similar in that it sets up an electrostatic field around it that forms a capacitive link with things. So let me turn this on. I'll show you how it works. It's running on a 9-volt battery, by the way. It draws a lot. It draws 300 milliamps, a chunk. Okay, now this is on now, and you can see this is being powered wirelessly across a distance of about a foot, 10 inches to a foot, and it does run one of these little motors. And there was a comment made that all this was doing was exciting things. It was not actually transferring any energy. And this is proof that it is. These things run on very little, but they do require amperage. It requires an amperage to run one of these motors, and it's not simply an excitation. It's actually transferring energy across this gap. Here is another showing of the energy that comes off of this. And then of course the famous one is the light bulb here that lights up. And somebody said a comment, it's just exciting the gas in the tube. And perhaps that's right, but like I say, my feeling on this is there's a lot more going on here besides just exciting the air or the molecules in that bulb there, because of that, and the fact that that is actually being driven wirelessly across that air gap. And it's not an inductive link. If you were to rotate this 90 degrees, it would still run, and Dr. Stifler did some experiments where he showed that this is not an inductive link. This is a capacitive link through space. But anyway, I thought I would share that with people, that these little motors that you can get out of those solar-powered toys will operate using one of those AV plugs, Avramenko plugs. And the capacitor that's in the circuit there is all you need, just with an AV plug on a receiver tower of some kind, and you can transmit the energy from an electrostatic device. It's quite easy to do. And here again, here's the field around this thing. Alright, thanks for watching.